when you start to use the new Elizabeth Line stations next year. Among its many achievements will be the first large-scale use of 3D printing in concrete. The use of 3D printing has made possible one of the more distinctive features of the future Elizabeth Line stations, the curved concrete panels that will line the inside of the passenger tunnels and some stations, and sinuously glide around corners in a way never seen before in a tube station. Although it has been technically possible to use concrete as a material in 3D printing for a few years, the objects made tend to be small as larger panels of the size needed for crossrail still have structural weaknesses in the design caused by the weak bonds between each layer as they are built up by the 3D printer. What the crossrail contractor fitting out the stations did was take a very different approach. They printed the molds instead of the concrete. Building molds to form concrete is a well-known technique, but it's very time-consuming and wasteful. The traditional method is to carve the shape out of a solid block, then cover the rough surface with a tooling paste to create a smooth surface. Not only wasteful and throwing away material that's not needed, the tooling paste takes, on average, 12 hours to set. Each traditional mold would take around 16 hours to make, and that's before you've even started with the concrete. For a project as large as Crossrail, which needs around 36,000 concrete panels, this was far too slow, too expensive, and too risky in terms of things going wrong. An alternative was needed, and 3D printing came to the rescue. An Australian company, Prefab, which happens to be a subsidiary of the tube station's fit-out contractor, Lang O'Rourke, has perfected a method of printing curved wax molds that can then be used to form Crossrail's unique station panels. It wasn't simple though. It took 3 years of experiments by James Gardner, the Australian architect who invented the technique to find a wax that would be suitable for use in concrete molds. Something soft enough to be used in a printer, and with a melting temperature to make it flow easily, but also hard enough to withstand the weight and the warmth that comes from curing concrete. Prefab uses a 6-axis gantry robot with interchangeable end effector tooling to coarsely 3D print a wax-based mold, then and subsequently polish the molds by removing the rough surface with robot milling tools, a combination of additive and subtractive manufacturing, to create a large, complex and smooth surface for the concrete. The huge advantage of 3D printing the molds is that prototypes can be made more quickly, typically 2.5 hours versus 16 hours. And is a marked change from the plywood models used just a few years ago on Crossrail's original test mock-up. In production, each panel mold is 3D printed from a red wax, and then concrete poured in as would normally be done in conventional molds. Once the concrete is hardened, the wax can be simply melted off, and most of it reused for the next panel. Although they're using 3D printing to make the molds, the casting process for the concrete itself is tried and tested, so there's no risk that the panels would have any unforeseen weaknesses later on. Lang O'Rourke is fitting out 3 of the Elizabeth Line's underground stations, Tottenham Court Road, Bond Street and Liverpool Street, requiring in total some 1,400 unique molds to cast the 36,000 different shaped concrete panels. The use of 3D printing also means that the laborious and expensive process of making up each of those separate molds can be avoided. The panels are being manufactured by the Lang O'Rourke subsidiary, GRC UK, who are using the Prefab technology in their Doncaster factory. When the stations open next December, not only will they be huge, but they will also represent the first large-scale use of commercial 3D printing in the concrete industry. You can see one of the curved corners and their 3D printed panels in the Transport Museum at the moment. What's on in London today or tomorrow or this weekend?